Okay, this is Unit 2, Day 5, Part 2. All right, so we basically just were evaluating the function f at -2, f of -3. So now it says calculate the average rate of change. Guys, they're asking for slope. Okay, they're asking for slope. So remember, your slope formula is change in your y's over change in your x's, or delta y over delta x. Okay, so ready? I'm going to do this. I'm going to go, and I'm going to go 22 minus -3. And because I picked the 22 first, I have to do 3 minus -2. Those all become pluses. And I get 25 over 5, which is 5. So that the f function has a slope, or an average rate of change, of 5. All right, I got to do the same thing for the g function. So g at -2 is equal to 9. And g of 3 is equal to 19. Again, how am I getting those numbers? I take -2, I go over to the g function up here, and I plug it in wherever I see an x. So 2 times -2 squared plus 1 gave me that 9. Okay, and plug in a 3. 2 times 3 squared plus that 1 gave me the 19. Now remember, it's y minus y all over x minus x. Okay, so I get, what is that, 10 over 5, because those become pluses. 10 over 5, I'm going to get 2. Same thing over here, just more examples. So f of 1 is equal to 12. F of 5 is equal to 32. And now, again, that's a coordinate. That's 1, 2. That's 5, 32. So, ready? Y minus y over x minus x. So I think that's what? That's going to result in 5. And then the same thing for the g function. So g of 1 is 3. G of 5 is 51. Y minus y over x minus x. That's what, 48 over 4, so that's going to be 12. So there we go. So not too bad. It's just knowing what they're asking you. Part B, the average rate of change for f was the same for both functions. So ready, look. So it said, so if you look up here, there's my f function. That was 5, that was 5, but these are not. Why do you think that's happening? Well, look at the f function. The f function is linear. And if it is linear, that means it's going to have a constant rate of change. Okay, so the slope is constant. So if you were to graph a line, okay, so if you look at this one, when you graph it, if you look at the equation, you're going up 5 over 1, up 5 over 1, up 5 over 1. So you know, we knew that this slope was 5 even before we did any of these. There's my slope right there. This is a quadratic. It doesn't have a constant rate of change. Okay, so that should make sense to you. All right, example 39. The table below represents a linear. So that means there is a constant rate of change. There's a slope. Okay, so you just kind of have to figure out right here. So how am I going to 1 to 5? Okay, and you're kind of jumping there. Okay, so you want to see what's happening every time. 4, 6. Okay, so this is what you can do. All right, so this means there's a constant rate of change. So aka slope. Now some of you will be able to figure out a pattern, but look, set up a proportion. Okay, you can pick these two because they're given, or you could pick these two. Okay, so I'm going to do this, change in y. So look at these two values right here. Ready? See those two values? So y is going from here to here, and x is going from there to there. So I could go -5 minus 1 all over 1 minus 5. So I get -6 over -4. And a negative over a negative is positive. That has a rate of change of 3/2. So 3/2 is my constant rate of change. Okay, so what can I do? You could use that constant rate of change. So that's your k. That is your k. So you could do y over x equals k. Or just set up a proportion. So now use this one. So look, right here, use this. set up a proportion. 1 over negative 5 is 11 over the y. You cross multiply that, you get y is 10. Why does that help me? Because look, that's now 10. Okay? Do it again. So I'm going to use 1 and negative 5, and I'm going to use that one. So I go 1 over negative 5 is x, because that's the x value, over 22. Cross multiply, you get 19. So that missing spot is 19. Look how easy this is. Why? Because it has direct variation, which means there's that constant. So I'm going to use 1 over negative 5, and I'm going to set it equal to 45 over the y. You cross multiply, and you're going to get that y equals 61. Okay? Not too bad. Last example here, example 40. Consider the linear function. Okay, so that graph's a line, there's a constant rate of change. Determine the y-intercept of this function by evaluating f at 0. Well, guys, you know what the y-intercept is if you know the basic equation of that line right here. Look, here's your b. That's your y-intercept. Okay? So we know that the y-intercept is at 5, which means it has the coordinate 0, 5. If you forgot that, look, plug 0 into that equation. It becomes 3 times 0 plus 5. You get f of 0 equals 5, and that gives you the coordinate 0, 5. You should all be going, ah, yeah, that makes sense. All right, part B here, last thing we're doing now. Find the average rate of change over the interval from the x values of negative 2 to 3. Okay, so ready? F of negative 2. You plug in negative 2 to the equation. So 3 times negative 2 is negative 6 plus 5 would be negative 1. Okay? And then you're going to do f of 3. So 3 times 3 is 9 plus 5 is going to give you 14. Okay? Slope. Y minus y. So look, I did this y minus that y. And then I got to do 3 minus negative 2. So I get 15 over 5, and 15 over 5 is 3. So the rate of change, which means slope, is going to be 3.